Welcome to ARI Live. I'm Mark Tier, the founder and CEO of Black Spectacles. Today we're going to be joined by guest expert Andrea Monroig-Torres, who's going to be walking you through a mock PPD practice exam. If you can think of any questions you'd like to ask Andrea during the Q&A, make sure to post them in our ARI community. If you're not familiar with our ARI community, you can find it at community.blackspectacles.com. We've actually pinned today's, let's say, discussion at the top of the community page. So community.blackspectacles.com, and throw all your questions there. If you're joining us for the first time, Black Spectacles is a leading test prep provider for ARI 5.0. Our test prep includes video lectures, practice exams, flashcards, and virtual workshops, all available online with memberships available for either individual architects or groups. And I want to mention to all of you, we recently released brand new video content for the PJM exam, which includes brand new lecture videos with motion graphics and 3D graphics, as well as scenario videos with new animation. So it's good stuff. Invite all of you to check it out. As a reminder, we also offer a referral program for groups. Whether you are and maybe we want to go to the next slide here, but whether, let's see here, whether you're a firm or a school or an AIA chapter or some other kind of group, just introduce us to your boss or HR or whomever makes the decisions in your group. And if they sign up, we'll provide you with a $250 gift card of your choice. So participate. All you need to do is follow the instructions on blackspectacles.com/group-referral. And those instructions are so easy. All you have to do is send an email to sales@blackspectacles.com, introducing us to your firm leader or your group leader, and we'll take it from there. Our next session for ARI Live will be December 14th of 2023, where we'll be discussing the CE exam. We'll be doing another mock exam. So again, another good opportunity to get some good practice in. And so you can go to, I'd recommend, just so you don't forget, and it's all good if you don't show up, but go ahead and register right now. Go to blackspectacles.com/podcast to sign up. If you're live right now, we just posted the link. So invite you to go register right now, just so you've got it on your calendar and you'll get the emails and so forth. And if you can't show up, no big deal. We'll send you the recording anyways. As I mentioned a moment ago, today we're going to be posting a thread in our online ARI community to answer any questions you might have. You can either click the link I just shared in the chat box, which will send you to community.blackspectacles.com, or you can find it in the ARI Live section of our ARI community homepage. Everyone who posts in our thread today will be eligible to win a free Black Spectacles t-shirt. So head over to community.blackspectacles.com, and seriously, all you have to do is say hello. If you do that, you are automatically, let's say, eligible to win the t-shirt. But invite all of you to to post a question in there if you'd like to as we're going through the session. I'll be pulling those questions and sharing them with Andrea during the live session. So I will be monitoring our ARI community page for any questions. So if you have one, throw it there, and I'll promise I'll pull it out so that we answer it during the live session. Let's see here. One other fun thing. It's November. Black Friday's only a couple of days away. So at the end of the show today, I'll be sharing our Black Friday discount code for 30% off of any membership. It's our biggest sale of the year. And so excited to share that with you. So with that, I would love to welcome today's guest, Andrea Monroig-Torres. In addition to working with us here at Black Spectacles, Andrea is an architect based in Washington, D.C., and is licensed in Puerto Rico. Today, Andrea will be sharing her screen during today's ARI Live. So we recommend watching the webinar to better see how we work through the material. So with that, welcome, Andrea.
Thank you, Mark. Thank you, everyone. Hello, and everyone. Welcome to our podcast today. As Mark mentioned already, today we're going to be doing a mock exam for PPD. More specifically, we're going to be talking about building systems. So with that, let's go ahead and get started with the first question. A big company wants to renovate and expand an existing building located in Arizona. The client wants to foster sustainable economic development with this expansion. The building will be designed as a Type B occupancy, construction with an occupancy per IBC 2018 with a total occupant load of 540, distributed along multiple offices in 5 levels. What would be the most appropriate system, HVAC system, a central or a local system? I'm going to give you a few seconds to think about it, and then we're going to discuss the answer. All right. So in this case, we could go with both. If we are talking about individual offices, we would do a local system with a system in each office. Usually a local system is intended to serve one zone. If we have multiple offices, we would have one system in each office. The system is self-contained, meaning the source, distribution, delivery, and control components are close coupled and generated within one package located in each office. If we had an open floor offices instead of individual offices, then we could go with central system. A central system serves multiple zones from one location or one zone from a distant location. With a centralized cooling and heating system, a distribution system is also required to transport the conditioned air from its place of origin to the various zones. This means that we would have multiple ducts running within the building, difference with from the local system where we would have just a package unit inside of the space. Question number 2. Okay. So a big company wants to renovate.
I don't see any. Just as a quick heads up, I don't see any questions right now, Andrea. If anyone has any questions on these specific questions we're going through, please drop them in the community. Nice to see a couple of people posting already, but I don't have any questions right now. So go right ahead. Sorry to interrupt you there.
No, you're good. I would love questions. All right, so question number 2, we're talking about the same case study. A big company wants to renovate and expand an existing building located in Arizona. The client wants to foster sustainable economic development with this expansion. The building will be designed as a Type B construction with an occupancy per IBC 2018 with a total occupant load of 540, distributed along multiple offices in 5 levels. What central HVAC system would be the most, what local HVAC system would be the most appropriate given the client request and building use? A, CAV or constant air volume with terminal reheat and return grills. B, variable air volume or VAV with VAV box and return grills. C, fan coil unit with rooftop mounted dedicated outside air ventilation or DOAS system. D, variable refrigerant flow with rooftop mounted dedicated air ventilation or VRF with DOAS. I'm going to give you a couple of seconds again. All right, and so the answer would be a fan coil unit with rooftop mounted dedicated outside air. So with a fan coil, you can work with, if we can go to the next slide for a second, so we can expand a little bit more on each of these. Can we go to the next slide?
Hey, Patrick, can we go to the next slide, buddy?
No? Okay, sorry, go back.
Maybe back, maybe back.
Yeah, all right, let's expand a little bit about on each of them. So like I was saying, for a fan coil unit, you would use it for a multiple zone system. It would be localized in each office or in each unit. The fan coil system does not supply fresh air, which is why we are adding the dedicated outside air ventilation to provide fresh air into each unit. Because with the fan coil, we would need a separate ventilation system. That would be the DOAS or it would be injection air. The way that the fan coil unit works is heated or cooled water comes through the pipe or through pipes or coils into a fan coil unit, which is the package that would live in the unit and would supply the conditioned air. With this system, the temperature is controlled by modulating a modulating valve on the heating and cooling pipe. So each office or each space would be able to control the temperature in the unit individually. Now, let's talk a little bit about the other systems and why this one would be the most appropriate for offices. So the constant air volume with reheat terminal is a central system, like we mentioned before. It serves single zones or single units. The way that it works is with constant air volume having a temperature controller in the unit that controls basically the heat or cold water that comes from the air handling unit or the chiller or heater. So you would need one single thermostat in each air handling unit, meaning that if you want to control multiple spaces with, or have the ability to have multiple spaces with different temperature, you would need a CAD or air handling unit individual for each space. That means that we would also have more ducts coming from each of the air handling unit to each space. So more space and more energy would be needed. For the variable air volume with VAV box, this is also a multiple zone system. So the same idea of the CAD would be apply here. The difference would be that in this case we would not be actually controlling the temperature that is going into the space. What we would be controlling is the volume of air that enters the space, and that basically would be the controlling elements of the air in the space. We would have a damper, and the thermostat basically would control that damper and close it or open it depending on the amount of air that we want in the space. If we wanted to provide both heating and cooling with this system, we would need a VAD box, because the system only allows either cooling or heating happening at the same time. So if we have cooling happening in the system, in the central system, then we would add a VAD box in each space that would allow for heating in the system. So again, this is more energy that we would be spending. Now, between the fan coil unit and the VRF, which are fairly similar systems in the sense that they are both local systems that happen or are located in each space, and they allow for temperature to be controlled in the space individually. What would be the defining factor in terms of which one you would use could be the sustainability factor and then the noise factor affecting both systems. You could use both of them for repetitive spaces, talking about apartment units or hotel rooms or offices, individual offices. You could control the temperature in each of them. Now, you would not want to have a noisy equipment in, let's say, an apartment building. But in terms of an office building where you would want to have a noisy, not noisy equipment, but something that produces more noise so that the noise could help with acoustic between offices, then in that case you would use the fan coil unit, which again is a noisier equipment than the VRF. The other element is the sustainability factor. With the fan coil unit, as we explained before, the fan coil unit also needs to add a ventilation element, which would be the DOAS or induction air. So in that case, it would not be the most sustainable system, but the VRF flow with the DOAS system is a more sustainable system. I'm sorry, because you could use the same system for various spaces. You can use, if you compare this, for example, to the fan coil again needs one equipment, one system per room. With the VRF, you could use the same system for 3 apartment units, or you can use the same system for 3 different offices, and you would still be able to control the temperature in each of these spaces. So that's mainly the difference between the fan coil and the VRF would lie in the use that you would give each of them. If you're talking about hotel rooms or offices where you could or would want to have some extra noise added to the space to help with the acoustics, some white noise added into the space, then in that case, you would use the fan coil. The VRF would be better suited for smaller spaces, apartment buildings where you would not want the noise, and you would also want to take advantage of the sustainability factor of the system. All right, so question number 3.
Actually, let's pause right here. We do
Yeah.
have a couple of questions. And again, I
great.
want to invite everyone to post their questions in our ARE community. Just go to community.blackspectacles.com. But let's see here. There were a couple of questions. Moshe asked, why would we need heat in Arizona? And the thought was, Arizona is a desert. But some other people were going back and forth and maybe sort of suggesting that in some places it does get cold. So do you want to maybe address that in general?
Yeah, no, of course. Thank you for that question. Yeah, definitely. If we are on a desert, the idea is that we have very hot days, and then during the night we do get the temperature drop. We get a great drop in temperature at night. But I'm not talking specifically in that case when I'm explaining about the heating. I'm just talking in general about the system, trying to let you know that we can do both heating and cooling with the system. And I just wanted to clarify that in the explanation of each system, so that you can get the whole picture of the system, not the place in this case. But completely, the Arizona aspect of the question, yeah, you're definitely right. We might not need the heating in Arizona. Also, I am gonna use that question, and I also see the type B now mentioned there. I think it's important as well to understand what parts of the questions are important for the answer, and what parts of the statement that are given in a question are statements or points that we need to actually use or not. If it's just there for filling the question, I think it's a good thing to try to decipher and actually understand what part of the question is needed for the answer. And the part of the Arizona part, yeah, I completely agree. It's completely needed for the questions that we're answering today. Now, the type B construction, the heat and seat load, it's not completely irrelevant for these kind of questions right now. I just added them for confuse a little and trying to understand what part of the question is actually important or not when we're talking about this kind of questions and statements.
Got it. And then wanted to make a note here. Let's see, Gilda as well as Jenny had asked a couple questions related to the type of system. So is there such a term as dedicated air ventilation? But maybe the question here is, why is a fan coil system a centralized HVAC system? Shouldn't it be a localized one?
Yeah, it is a local one. Yeah.
There we go. Okay, beautiful.
You're correct.
Beautiful, beautiful. All right, feel free to go right ahead. Thank you.
Right, so 20 years, question number 3. 20 years have passed and the same building will be converted to an apartment building. Water heaters will need to be updated for a more appropriate system for apartment building. Which would be more efficient, a centralized system or a point of use system? A, point of use, or B, centralized system? Right. Okay, so in this case, we would want to have a centralized system. The centralized system would be a gas heater with storage tank. It would be an electric resistance heater with storage tank, or a gas or electric resistance with heat pump heat recovery system. A point of view kind of system would be gas tankless heater. These are energy efficient, produce more hot water or at greater efficiency and high initial cost, or an electric tankless heater that adds to the peak demand on electric grid, not energy efficient and can only supply a limited amount of hot water, and it requires no minimum floor area. Kind of the same explanation as with the HVAC system. The point of view water heater lies in the same place in the unit, in the place where it's going to be used, basically. Whereas a centralized system would be divided in 2 parts. It would have a place where the water is getting heated. That would be the gas heater or the electric resistance. And then you would have a storage tank where again the already conditioned water would live in the storage tank, and that's the one that would go to each phase where it's going to be used. In this case, when we're talking about an apartment building, we would want a centralized system that we can give maintenance in one room outside of the actual units. If we were talking about a condo building, for example, in that case, we would want to use, or it would be more appropriate to have a point of use heater, water heater. In that case, each individual condo units would want to give maintenance to the system, so they would have it within the same unit. So there would not be a general maintenance place for this kind of use. All right, we can go to the next slide. All right, so basically going into the same topic, the client developing the new building would like a sustainable building with optimized system and a controlled budget where every system is selected based on cost, efficiency, and sustainability. Which water heating system is the most appropriate for the new apartment building? A, single electric resistant tank with multiple water storage tanks, heat recovery system located near exhaust vents, central solar water heater with decentralized tankless heating coils, and D, single gas tank with recirculating pump. So we would go with C, the central solar water heater with decentralized tankless heating coils. As we can see in the statement of the question, we want to have a optimized system on a controlled budget with every system selected based on cost, efficiency, and sustainability. When we use the central solar water heater with decentralized tankless heating coils, we have a highly sustainable system. We have higher initial cost, but then we have lower cost life. It requires minimal floor area. We would have the solar system happening in the roof probably, or outside of the building, obviously. Then we would have separated heating coils that would be closer to each unit, and those would be the ones producing the heat that would hit would be transforming the heat gain from the solar system into the piping poles that would be then distributed into each unit. Then the downside of the system would be that the efficiency would vary depending on climate zones. If we go back to the original statement, we're talking about Arizona. That means that central solar heater would be appropriate for this climate zone because, like someone mentioned earlier, we're talking about the desert. So a solar system would be very appropriate. Talking a little about each of the different options that we have here, a single electric resistant tank with multiple water storage, it would be inefficient because we would be wasting water and energy, and it has uneven heating in units, meaning that the higher unit in the highest floor would have the water would not be as hot as the one closer to the heating system or the heating element would make, and this would make the system inefficient. If we go with heat recovery system located near exhaust vents, it would have a higher initial cost as well, and it is usually an added element, not a primary system. You would also have to add a different system. It is a great idea for sustainability because you would be reusing energy, but again, you would need a central system before adding the heat recovery system. Then the single gas tank with recirculating pump, it's kind of the same idea as the single electric resistance tank. The difference is basically the way that you're producing the heat. It is more efficient than the electric resistant tank because you are not wasting energy as you are or adding to the peak energy, the peak electric system. But it's still very wasteful because you are currently constantly pumping water, which means that you are actually wasting that water. And if you add the recirculating pump, you are also wasting electricity because you have the pump running constantly. So that would add a lot to the electricity budget. All right, we go to the next slide.
Before we do, Andrea, it looks like there's a couple of people that have sort of the same question. How is higher initial budget, how does that work with initial cost?
Oh, so basically the initial cost is the price of buying the system. The solar heater are more expensive as an initial cost, meaning that the actual equipment are highly expensive right now. But then during the life of the system, since you are not spending on electricity, then the life of the system is going to return that initial cost with the electricity bill, basically. The initial cost, basically that's the idea. The initial cost is the price of the system and how expensive or not expensive that system is to put to function, basically. Then the life of the system could be that the life of the system is more expensive or not. Let's compare the electric resistant tank versus the solar water heater. With the electric resistant tank, the system itself and buying the system and putting the system to work is way less expensive than putting a solar water heater to work and buying the equipment. But during the life of the system, the electric resistant tank is going to be more expensive to operate because you're going to have a higher electric bill. You're going to have higher maintenance cost versus the solar water heater, which is going to reduce those electrical costs. It's not going to add to the electric grid, to the peak electric grid, and then the maintenance of the system is way simpler than what the electric resistance is because you're going to have less equipment as well. So you have less things to maintain. That means that you have to put in context the budget for each system. And in this case, if we are talking about optimized system based on cost efficiency and sustainability, we have the three elements, then we can say that the solar system is better because yes, it's going to have a higher cost, but then along the period of time, you're going to have more savings than what you would have with the electric resistance. Even with the electric resistance, it's cheaper in the initial cost. So you would have to put it in a balance. If the statement did not mention the efficiency or the sustainability part of the question, it would just base on cost, then yeah, the single electric resistant tank would maybe be a good option as well. Or the single gas tank also would be a good option for the question. What makes it in this particular question, what makes it better to have the solar water heater is the cost, efficiency, sustainability part, and the Arizona part. Because everything in those 4 items make it work better with the solar water heater equipment.
Awesome, thank you.
Right, we can go to the next question. All right, so again, we are using the same statement as before. The client has decided to provide light fixtures in all units. They would like to decide again on a sustainable, low-cost, long life option, which would be the appropriate light source. A, incandescent, B, discharge, C, high intensity discharge, or D, solid state light. All right, so in this case, we would go with the discharge lamps, discharge light fixtures. Discharge include fluorescent lighting, neon, and cold cathode lamp. Again, let's discuss a little about each of them. Incandescent would be an incandescent lighting or a halogen lighting. High intensity discharge would mean a mercury light or a metal halide or a ceramic metal halide or a high pressure sodium or an induction. And a solid state light would be the LED. Now, in this case, it's a bit hard sometimes to make the difference between them in terms of which one would be the best option. because as we already know, the LED lights are the best option in general in terms of lighting, because are the most efficient and less expensive along the way option. Now, in this case, the difference would be, or the deciding factor would be, the use that we're giving them, because in this case we are talking about an apartment building. If we use the solid state light, the LED would need to have a controller, or the electric source would be the electric source would live within the equipment, basically. In the discharge option would be connected to the electric grid of the building. So that means that the maintenance given to each of them would vary. So with a discharge lighting fixture, the maintenance would happen outside of the unit. In the solid state line, if there is a problem with the lighting fixtures or anything happening, then you would actually have to go into the unit to change the unit, basically to change the LED or to figure out what the problem is. So in that case, you would actually have to go inside of the unit instead of having a centralized space with an electrical room that you can go and see what the problem is. Basically, that's the difference. If we are doing, for example, a condo building, in that case, we would actually want to do solid state light, because in that case, every person would be in charge of the maintenance and in charge of everything that happened in the unit. So that means that we would want to have light fixtures that it's basically contained within the unit. And in that case, the LED, it's a way better option. But again, in this case, where we're in an apartment building where we want to have a more centralized place, then we would do the discharge, so that we can take out of the unit the power factor of the light fixture. Right, we can go to the last question.
That was the last one there, right, Patrick?
Okay. Oh, so we're okay.
Got it.
Well, yeah. If I can take a few minutes, then in that case, I wanted to talk a little more in that case about zooming in a little into the discharge light source. So if the fluorescent light fixture, the difference between the fluorescent neon and cold cathode lamp. So the fluorescent has, in this case, we would select the fluorescent light fixture for an apartment building, because these have high efficacy. They have a good color rendition index, and the life expectancy of this light fixture is 46,000 hours, and they have low energy cost as well. For the reasons that I was mentioning a little earlier, the typical uses for this kind of light fixtures are apartment and offices or spaces where diffuse area lighting is preferred. Now, neon is, yes, a high efficacy light fixture, but it has a low color rendition index. It has a low light output, and it's usually developed with special colors and shapes. And so those would be the typical uses, places where you need different colors and different shapes. That's where you would use a neon light fixture. Then the cold cathode lamp, it's low efficacy and it has a low color rendition index as well. And so the typical uses would be for decoration. Before the fluorescent was made or was highly available, the one that we would have used was the cold cathode lamp, but the fluorescent is more efficient, so that's why the cold cathode lamp is only used nowadays just for decoration. We basically replace everything else with the fluorescent light. Then the metal halide, it has a high efficacy as well and a good color rendition index, but then the life expectancy is lower than the fluorescent light, and the typical uses would be bigger spaces with stores, basically offices, schools, those kind of places where you want to have a good color rendition index. You want to have a high efficacy, and the life expectancy is good. It's still good. It's still 20,000 hours, but you can basically replace them with no problem. Yeah, basically that's the difference between those 3-4 light fixtures, and that's why we would use the discharge and the fluorescent specifically for this kind of option. And that was now the last question.
Yeah. That's great. Thank you, Andrea. I guess one note just to make to everyone, just know there's a couple comments about folks, wondering about NCARB writing sort of trick questions and things like that. But the thing I'd note to you is, there's very much a science to writing, questions on these exams. And we use here for our mock exams, we often use these sort of to teach specific concepts. And so here's a great opportunity to learn a little bit more about the discharge, type of light source. The thing I would recommend to all of you is, again, NCARB tries to not write, trick questions. Usually if there's a trick, the trick is in the actual wording in the actual question. And sometimes it's easy to kind of like skip over, one word in a question, and that question, that word is the thing that kind of makes it a little bit tricky. So anyways, that would be just something to kind of think about in terms of test taking strategies. We did have one question. Would love to go back to the first slide here. One question here in the ARE community I do want to point out. And the question was, maybe there was a little confusion, so it could be that. S. Dubinsky wrote that, Andrea, maybe you had mentioned that the answer is both, and said that the exam wouldn't allow for both. So what is the right answer in this case? Could you comment on that?
Yeah, of course. So we are talking here about the HVAC system. Yeah, here we would go with a local system because we're talking about offices. If we had the, okay, I know I get the confusion. So if we were talking, if the question was talking about individual offices, then we would do a local system with a package unit in each system. In this case, we were talking about fan coil units. Now, if the offices were an open floor space, in that case, we would go with a central system. I kind of wanted to have both options there so that you could visualize it better and understand it better. If you had an open floor office, then you could do a central system where you would have ducts running into each section of the open floor and supply the conditioned air. If you had individual offices, then in that case you would have local systems packaged with inside each individual office. That way you can kind of visualize which system is better for what kind of use.
All right. Well, thank you very much, Andrea. That's going to be all for today. So just a reminder that our next ARE Live, I do have a couple of updates for all of you here briefly. Our next ARE Live will be on December 14th, and we'll be discussing the CE exam. So I'd certainly recommend registering for that, just so you get it on your calendar. And if you're not able to attend, of course, we'll send you the replay. You can go to blackspectacles.com/podcast to sign up, or check out the community page. As I mentioned at the beginning of our show, we recently released some new content on the PGM course, so check that out. As a reminder, we also offer a referral program for firms and schools, where if you introduce us to your boss or HR, and if they sign up, we'll give you a $250 gift card. To participate, follow the instructions on blackspectacles.com/group-referral. I mentioned that today we'll be handing out a free t-shirt for everyone who posts their questions in our ARE community. And the winner for today is S. Stepper. I'm not sure if I'm saying that right, but SS Stepper. So thank you so much for posting in our ARE community. And just a reminder, if you'd like to be eligible to win a t-shirt the next time, feel free to post your question on our featured topic during the next ARE Live. And the thing I'll mention, we use that as a great resource because our ARE community is always active. It's not just active for ARE Live. It's a place you can poke around and you can ask questions, while you're studying. And then lastly, as a thank you for participating today, we'd like to offer you a 30% discount off of any membership with the code SAVE30Live. This coupon code will be valid until November 27th. So if you're ready to start studying, go right ahead and you have a coupon code. And with that, I want to say thanks for watching. We look forward to seeing you next month.